Hello everyone, myself Sujithra. I am working as an assistant professor in the Department of ECE in AVS College of Technology, SALEM. Now I am taking Adhoc and wireless sensor networks for 7th semester. Now we will see a topic in this subject. First of all, we will see what is meant by a wireless sensor network. It is formed by group of sensors which are used to play several roles like sensing, monitoring, gathering and forwarding the data. These are used in many applications like military, agriculture, home security and machine failure diagnosis in industrial sectors and biological detection. It is also used in several disaster relief applications like forest fire, etc. Now we'll see what are the challenges that occur in forming a wireless sensor networks. The basic unit of wireless sensor network is sensor node. It is known as moat. Each sensor node has 5 main parts. One is onboard sensors and then processor, memory, transceiver and power supply. This together act as a sensor node and it performs the functions like wireless communication, signal processing, topology or connectivity management, storage of data, routing, data analyzing, digital encoding, error correction, scheduling, self-assembling and clustering. These are all the main functions of a sensor node. Next, a sensor network. It is nothing but large number of sensor nodes are deployed either inside or some close area to the phenomenon which we have to sense for the applications. Next, we will see about the challenges of wireless sensor network. First one, type of service. Basically, in conventional communication network, we move bits from one place to another. Here, in wireless sensor network, we have to, in addition to this communication, we have to increase the scope of interactions to the specific geographic region where we are employing that networks. For this purpose, new paradigms, that is new set of rules, that is protocols using new interfaces and new ways of thinking about service of the network are needed. Next one is quality of service. Requirements like multimedia applications, bounded delay or minimum bandwidth are irrelevant. Here, packet delivery ratio is considered. What is meant by packet delivery ratio? It is nothing but the ratio of number of packets delivered in total to the total number of packets actually sent. But in some cases, we need only occasional delivery and in some other cases, very high reliability is required. In such cases, this packet delivery ratio is an insufficient metric. So, we adapt some other quality concepts like reliable detection of events, approximation quality of temperature mapping. The next one is fault tolerance. Mostly the problems like nodes run out of energy and in some cases there might be damages or there may be permanent interruptions occurs. In such kind of cases, fault tolerance is also needed. To achieve fault tolerance, deployment of redundant routes to make the node to function in such case of failures. Next, lifetime. Wireless sensor nodes are powered by small batteries and these small batteries are of limited energy. This limited energy supply constrains the lifetime of a sensor network. In wireless sensor network, energy is lost while sensing, transmitting and receiving. Even if the node is in idle state, there is also an energy loss. The recent challenging technologies in wireless sensor network is to increase the energy efficiency. As the nodes are powered by battery, there is only limited lifetime. Replacing new battery in dead node is the current solution. The battery level of sensor node is limited, so energy efficient improvement is a major challenge. Next, scalability. Wireless sensor network consists of huge number of nodes. Hence, the nodes are deployed in the environment correctly. Whenever we have to extend the application, we have to add new sensor nodes. For such cases, the employed architecture and protocols must be able to scale to these numbers. Next one is wide range of density. Here, node density is the number of nodes that are used in a particular area. This node density vary on applications and it also vary on time and space where we are using the network. Next one is programmability. Here, the nodes in the wireless sensor networks should be programmable and their programming must be changeable when new tasks are added to the network. It is not only necessary for the nodes to process the information, but also they will have to react flexibly when there is a changes in their tasks. Next, maintainability. Wireless sensor system has to adapt features to overcome some of the difficulties like depleted batteries, failing nodes, and addition of new tasks. It has to monitor own health and status to change operational parameters. In this sense, the network has to maintain itself. It could be also able to interact with external maintenance mechanisms in the network where they are operating to ensure its extended operation at a required quality.